In Poisson distribution, we have discussed how to calculate constant values in Poisson distribution, how we can calculate arithmetic mean, how we can calculate standard deviation, variance, measures of skewness and kurtosis we have learned in our last one video. In today's video also we are having some more question related to the constant value of the Poisson distribution, because so many times I have seen the question related to the Poisson distribution in the examinations. So in today we are having we will do some graded problem of the Poisson distribution. First question is like this. If the very first question we are having, to first one, in a universe the proportion of defective item is 4%. Probability of having defective item is 4%. Okay. Find the probability of not more than 2 defective in sample of 10 items. The question is this: as a universe, probability of getting defective item, this is 4%. If the sample size is 10, then calculate the probability of not more than 2 defective item is over there. So it means not more than 2 item defective we are to calculate. Okay, not more than. So here the probability for defective item, that is 4 upon 100. So arithmetic mean of this, that is NP, that is 10 multiply 4 upon 100. So x bar m is equal to 0.4. e raised to power minus m is equal to e raised to power minus 0.4. We can calculate the value of e raised to power minus 4 with the table. So if we will see the table of e raised to power minus m 0.4, that is 6703. If you will see the table value of chi square, this is 0.6703 is there, this one 0.4 up to 0, that is 0.6703. We are having another one formula for that e raised to power minus m, that is reciprocal of antilog 0.4343 multiplied by m. With the help of this formula also we can calculate e raised to power minus 4. So that is reciprocal antilog 0.4343 multiply m value is 0.4. So we will calculate 0.4343 multiply 0.4, that is 0.1737. So this is reciprocal antilog 0.1737. So we will see the antilog of this reciprocal 0.17. We will see the antilog. We are having the antilog table also in our book. So we will go through with the antilog table. Already I have shown the antilograments table is over there. So in antilograments we will see 17 at 3, that is 1489. 0.17 at 3, that is 1489. You will see, if you will see 0.17 antilog, that is 1489. And the difference of 7 is 2. So firstly we will having the multiplication of this 0.4343 0.4343 multiply by 0.4 1737. Okay. So e raised to power m, some difference is over there in e raised to power value. Firstly we will check the e raised to power minus 0.4. E raised to power 0.4 e raised to power minus m. So e raised to power minus 0.4. So value is 6703. But if I am seeing with the help of this 0.4, so reciprocal okay. After reciprocal we will not get the confusion. 0.1723. So I am seeing this 0.17 anti-log. We are saying 0.1723, that is 1493. 0.1723 1493. First 0.17 we have seen up to this 0.1493. And the difference is 2. What we have seen 0.17, this is 1493, 0.17 up to 3, and the difference of 7 is 2. So that is 1495. So this will be 1495 and 0, so point will be here. So the reciprocal 1.495. For getting the reciprocal of x, that is 1 upon x. So reciprocal of 1.495. So 1 divided 1.495. So we will having 1 divided 1.495. So that is 0.6703. So that is 0.6703. So this is the method with which you can calculate e raised to power minus m. Second method, you are having the e raised to power minus m table is over there. So you will see 0.4 at the 0, that is 0.603 is over there. In question also 0.6703 is given. So if given in the question, we not want to do this, and we not want to see in table also, because already we have given that e raised to power minus 4, e raised to power minus 4, that is 0.6703 in question. Question given is over there. So now we are to calculate. The question is this: the probability of having a defective piece is 0.4%. Is 4%. It means up to from 100, 4 items are defective. So calculate the probability of having two, if not more than 2 defective. We are to calculate probability of not having more than 2. Not having more than 2. It means probability n e raised to power minus m, m raised to power x upon factorial s. This is the formula. So not more than 0, it means the probability of 0 plus probability of 1 plus probability of 2 defective. Not more than 2 defective is over there. So the defective may be 0, defective may be 1, and defective may be 2. Firstly we will calculate the defective may be 0, then 1, and then 2. Then we will have it not more than 2. So for probability x is equal to 0. N is not given, so we don't want to write the n is here, because small n is given, capital N is not given. That is e raised to power minus 0.4, 0.4 raised to power 0 factorial 0. So this is 0.6703 multiply 1 upon 1. So first one is 0.6703. Px is equal to 1 defective, that is 0.6703 multiply 0.4 divided by 1. So that is 0.6703 multiply by 0.4. Point 2681. 0.2681, and probability of getting 2 defective, so that is 0.6703 multiply 0.4 raised to power 2 multiply by 2, that is 0.6745 multiply 0.16 divided by 2. 0.0536. 0.0536. So up to 2 defective. 0.6703 plus 0.2681 plus 0.0536. So the total is 0.992. 0.9920. So the probability of not having more than 2 is 99.2% probability is this, that haven't more than 2 defective in 100 pack. It means in 100 pack 99.2% of packing having not more than 2 defective is over there. We are to calculate this. Okay. So with the help of this Poisson distribution we can calculate what the question is asking. You will go through with the question and then answer the question, no problem at all. Very easily we can answer the question. So second question is over there. Post experience show that a plant have an average 4 industrial accident in per month. Find the probability that a certain month less than 4 accident will occur. Okay. This is the probability that in a month in a plant approximately there is a 4 accident is over there. So arithmetic mean of the accident is 4. Okay. Then firstly question is saying that in a industrial past data show that in a industry approximately average there is a 4 accident is over there. Secondly, I am repeating the question. Past experience show that in a plant of an average 4 industrial accident per month. Find the probability that in a certain month less than 4 accident will occur with the help of Poisson distribution. So average 4 accident is over there. So e raised to power minus m, that is e raised to power minus 4. So the very first we will calculate e raised to power minus 4 value is over there. In this question the e raised to power minus 4 is not given. So firstly we will see the e raised to power minus 4 table is over there. E raised to power minus m value is over there. So 4 that is 0.01832. You will see this 0.01832 e raised to power minus m. So that is 0.1832. This is from table. We are having another one method to calculate this, that e raised to power minus m, that is and reciprocal antilog 0.4343 multiplied by m. So that is reciprocal antilog 0.4343 multiplied by 4. M value is 4. So we will see 0.4343 multiplied by 4, that is 1.7372. So that is reciprocal antilog 1.7372. So we will see the antilog of this reciprocal. We will see antilog table 0.73 difference is 7. So the very first we will see the antilog. This is antilogram table. Here we will see 0.73 difference of 7, that is 5458.7, that is 5458 if you can see in this, that is 0.5458, and the 0.73 see at 7 and the difference of 2, so 0.73 that is 0.5458 and the difference is 2 is 3. The difference is 2, that is 3. Okay. So the difference is 3. So that is 1645. So there will be 5461 and here the 1 is, so dot will be here. So the reciprocal of this, that is 1 upon 54.61. So 1 divided by 54.61, so this is 0.0183, 0.01832. So we are having two methods for calculating e raised to power minus n. We can calculate direct with the table, and we can calculate e raised to power minus m with the help of this formula is also. So whether you can like e raised to power minus m table will be also available, anti-log table will be also available. So I think the better you should having the direct value of e raised to power minus m. Now come to the another things. We are to see less than 4. So p x is equal to 0. So that is e raised to power minus m, m raised to power 0 upon factorial 0. So that is 0.08132 multiply 1 upon 1. So first one is 0.01832. P x is equal to 1. So e raised to power minus m, m raised to power 1 upon factorial 1. So therefore 0.01832 multiply 4 upon 1. So first one is 0.1832. Second is multiply by 4, 0.0732. 0.0732, 328. Next one, px is equal to 2, that is e raised to power minus m, m raised to power 2 upon factorial 2, that is 0.1832 multiply 4 raised to power 2 upon factorial 2. So multiply by 4 this value, multiply by 4 divided by 2, 0.1465, that is 14656. Px is equal to 3. So e raised to power minus m, m raised to power 3 upon factorial 3. So therefore 0.1832 multiply 4 raised to power 3 divided by factorial 3. So multiply by 4 divided by 3, 0.1954, 0.1954. And last one we are to see the probability of last one, probability of 3, okay, less than 4, okay. We are to calculate only the less than 4 probability, less than 4. So less than 4 is probability of 0 plus probability of 1 plus probability of 2 or probability of 3. So we will add all these. So addition is 0.43357, 0.43357. So the percentage chance of this is 43.36% chance is over there. This is 43. That in this industry there will be less than 4 industrial accident in a certain month. In a certain month there is a 43.36% chance that in certain month there will be less than 4 accidental industrial accident in this or there. So with the help of this Poisson distribution we can calculate so many calculation is over there. One more question we are related to the Poisson distribution. Question number 3. Question number 3 is over there. In a factory, the average number of defective needle is 3%. 3% needle is defective in a factory. And the packing of 50 is over there. In a factory, the needle factory is over there. In a factory, it's seen that the matchbox have 3% defective matchsticks is over there. Each matchbox have 50 matchsticks is over there. 3% of this will be defective is over there. So with the help of the Poisson distribution, calculate various constant value of the Poisson distribution. Okay, firstly we will having, againly you should listen this question. A matchbox factory making the matchbox, they are seeing that average 30%, 3% of the matchsticks have defective. It means they are not having for burner everything. Each matchbox have 50 matchsticks is over there. So the very first calculate the various constant of the Poisson distribution. So firstly arithmetic mean of the Poisson distribution, that is NP, that is 50 multiplied by 3 by 100, so that is 1.5. That is standard x bar. Standard deviation is NPQ, Q is equal to 1, so that will be standard deviation is M, so that is 1.5 under root. So we are having under root of 1.5, 1.224. Third question, first one, second one. Third constant variance, that is M, so variance will be 1.5. Fourth, measures of skewness, that is beta 1, that is 1 upon under root M, so that is 1 upon 1.5, so that is 1.1224. So 0.816. And last measures, that is called kurtosis. Measures of kurtosis, that is beta 2 is equal to 3 plus 1 upon M value is over there. So 3 plus 1 upon 1.5 is over there. So this will be 3.67. So these are the constant values in the Poisson distribution. We have calculated arithmetic mean, standard deviation, variance, measures of skewness and measures of kurtosis. Only we have to put the values in the formula and we will get the values of this. Next, in this same question, something more question is over there. So calculate all these. Now in 10,000 packets a box is over there. Calculate the number of packets which have no defective, which have one defective, which have two defective, or which have three defective. These matchbox are packed in 10,000. So the calculate how many packets have zero defective among 10,000 matchsticks. How many have zero defective? So Px is equal to 0. Firstly M value is 1.5, so e raised to power minus M value we have to calculate. So e raised to power minus M value, if the in question this is given 0.2231. In this question this is given 0.2231, so we need not want to calculate this. Otherwise we are having firstly you should learn, it is also important, e raised to power minus 1.5 is equal to e raised to power minus 1 multiply e raised to power minus 0.5. So we will having e raised to power m table is over there. This is e raised to power minus m table is over there. So firstly we will see 1, that is 3678. So that is 0.3678. And for 0.5 value, that is 0.6065. So if this type of the value is over there, so we can calculate, because this is 1.5, so we have detected 1 and 0.5, so the e raised to power minus value is 0.3678, e raised to power minus 0.5 value I have seen with the table. So if in table directly 1.5 is not available, then we can having minus 1 and 0.5, so that is 0.3678 multiply 0.6065, So the value is 0.2231. So this is also 0.2231. So in this manner also you can calculate this. Now come to the point, probability of getting zero defective. So n e raised to power minus m raised to power f upon factorial x. So 10,000 multiply 0.2231 multiply 1.5 raised to power 0 upon factorial 0. So that is 2231 packets. Second, for one defective x is equal to, that was 0, x is equal to 1. So that is n e raised to power minus m raised to power 1 upon factorial 1. So that is 10,000 multiply 0.2231 multiply 1.5 upon 1. So we will having 2231 multiply 1.5 3346. So there will be 3346 packets. Next one, for having two defective, so n e raised to power minus m raised to power 2 upon factorial 2. So 10,000 multiply 0.2231 multiply 1.5 raised to power 2 upon factorial 2. So multiply by 1.5 divided by 2. 2510, that will be 2510. And last one, having three defective, so n e raised to power minus m raised to power 3 upon factorial 3, that is 10,000 0.2231 multiply 1.5 raised to power 3 upon factorial 3. So this will be 1255. So in this manner we can calculate the various value of this. First one is 2231, second is 3346, third one is 25110, and last one is 1255. So we can having expected frequencies over there. If we are to calculate the probability, so the probability will be, if they want probability, that is 0.2231, 0.3346, 0.2510 and 0.1255. Probability multiply by 10,000, we are getting this value. So I think with the help of this video, you may be able to learn how we can calculate the constant value in the Poisson distribution. I think this video will be helpful for you to calculating constant value in the Poisson distribution. Thank you once again.